This video is to review for the Unit 5 test, which is on radicals. And the intent of this video is to take you through the study guide that we'll be going over in class. So to be really specific about the directions, at least for the current school year, which the year I'm recording this, it is, I don't know when it is. It's February of 2023. So as of the time of this recording, I am planning to have a TDE on my review day for a day, which is the 14th. So that'll be, February 14th. So I won't be here to review for you. So if you are watching this on that particular day for that particular class period, what you are to do is to have a piece of paper out for your review, and you are to copy down all of the problems and their solutions. So like all of the work and the solution that goes with it, not just a pile of answers, okay? And you are to keep that with you to study for the test, and I will collect it from you on the day of the test. Now, the other people that need to do that are anybody who is watching this video in order to do a retake. So if you have already taken the Unit 5 test and you need to do it over again, you need to watch this video first and do the same thing on a separate piece of paper. You're going to write down every single problem and the solution. And remember, the goal is not to try to like memorize something to get like to memorize the test or anything. The goal is to learn the concepts, okay? Is to make sure that we're reviewing those concepts before we take the test. So if you're watching this on an A day and I am not in class, that is what you need to do. You are not to put it in the turn-in bin. You are not to try to give it to the sub or anything. You hang on to it and I will collect it from you on the day of the test. There we go. So there's our directions. So the first skill is to be able to simplify radicals of any index. So I'm giving you one to practice on that I think is a pretty generic problem here, and then there's more than one that's on the test. So the strategy that we covered in class for doing this was a prime factorization strategy, where we look for what the radical is going to undo. And so if I click over to my pen here. Okay, the hardest part of this is probably dealing with the 81. So off to the side, not in the middle of the problem. Okay, do not try to do the prime factorization right there because that's right underneath the problem and we want the problem to flow from top to bottom. So our scratch word goes off to the side. Most of you would factor 81 into 9 times 9. And then each 9 factors into a pair of 3s. And so I have 2. Now I want you to remember that that is 2 times the square root right there. Okay, or not square root, but cube root. And then 2 times the cube root of, and then we have 3 times 3 times 3 times 3, x times x times x, y times y times y times y times y. And what we want to remember is that a cube root undoes cubing. And so what I'm going to do is look at this prime factorization and I'm going to look for things that are cubed. Like, for example, right there, 3 times 3 times 3 is 3 cubed. So the cube root of 3 cubed is 3, just a regular old 3. Here I have an x cubed. So the cube root of x cubed is just x, and so I will have an x. And here I have a y cubed, and the cube root of y cubed is just y. Now I also have that 2 that was sitting there. This is where that top-down structure of your problem matters. So we want the 2 to come down from one line to the x to the next. We don't want like the 81 being factored like right in the middle of it because it breaks up the flow of the problem. And left under the cube root is a 3 and a y times a y. Now we want to make sure that we have this as simplified as possible. So we have it 2 times 3 is 6. And then we'll have the cube root of 3, and then y times y is y squared. Make sure that when you're doing these problems, you do not forget the index. So that's like a super common thing to do, is to is to forget the index. And so I do have to take off points for that, because if you leave it off, it's a square root, and that's not what we have. But if it's a square root, you'd be looking for groups of 2. It's a 4th root, you're looking for groups of 4. You probably won't see anything too much bigger than that, like maybe a 5th root or something, but because it gets too long, it gets to be too much to write out on a page. And so, think of when you're trying to write a test, you want to see if a student knows how to do it, but you don't want to tangle it up too much with how much space is being taken up. So there are a couple of problems like that are on your test, ranging from like simpler to harder. They are not the same, so there's different versions of the test. And remember, you want to focus on that concept, okay, the concept of what we're doing here, not like that you're going to see this exact problem or anything. Okay, then there's a chunk of operations with radicals. So be able to add, subtract, multiply, and divide radicals as indicated. It is so important that you notice what the operation is. So on the last test on polynomials, a lot of people lost points because they didn't do the operation that was there. Adding and subtracting polynomials is a lot easier than multiplying or dividing, and yet a lot of students just went and multiplied everything. Just multiplied every single problem. Even though there was a plus sign. So make sure that you are looking at the operation, and answers should be simplified as much as possible. So we have the 2 adding, subtracting examples here. And remember that when you are adding and subtracting, the radicands must match. So to add or subtract, the radicands must match. But before you can conclude that it is not possible to add or subtract them, you do have to simplify them as much as possible. And that might require some scratch work. So on your test, try to keep your scratch work off to the margin. There's usually plenty of space on the test for you to write. You just kind of move that scratch work off to the left or off to the right, so it's not in the middle of the problem. Here's what I mean by that. So you've got the square root of 45 minus the square root of 80. And so in order to simplify these, we probably want to get that prime factorization. So I'm going to move over here to the right and do my factorization. So 45, I know factors into 9 times 5, and 9 factors into 3 times 3. And then don't forget that the 5 is there. When I do a factor tree, I always try to bring down the other number, even though it's prime and I'm done with it, because sometimes if you leave it up here, you just notice the 3 times 3. Okay, and so my factorization on the 45 is 3 times 3 times 5. And then I'm going to factor the 80, maybe if I can write it, 80, and I know 80 is 10 times 8. And that will factor into 5. 10 factors into 5 times 2. And I know, because I've done it a bunch, that 8 will ultimately be 2 times 2 times 2. You could also do 4 times 2 and then break it down again. So that ends up being 5 times, and how many 2's do I have there? 4 2's. Okay, now these are both square roots, which means I am looking for pairs. I'm looking for things that are squared. So the square root of 3 squared is 3. And so that, and the 5 would still be underneath. And then over here, I have a couple pairs of 2's. So I have the square root of 2 squared, and then another square root of 2 squared. And then 2 times 2 is 4. And so 3 root 5 minus 4 root 5 is negative 1 root 5. Or you could write negative root 5. Like either of those would be fine. Now, there is some flexibility with this. So as I go back, I'm going to point out where you have some flexibility. Right here where you've got 2 groups of 2, and I moved each group out separately. So the square root of 2 squared is 2. The square root of 2 squared is 2. And then did the 2 times 2. A lot of you are going to look at that and say, okay, I'm bringing out 2 2's, which is 4. And you'll just do 2 times 2, and you'll jump right to this, and so you'd skip this step here, and that would be fine. Some of you also might know of ways to simplify those radicals without doing the prime factorization, and on your in-class test, that is fine to do as well. Notice that my scratch work is clearly labeled, like I can clearly see this is the 45 and the scratch work. My 80 is a little messed up there, but 80, and there's my scratch work for the 80, and it's not right in the middle of the body of the problem because this is my work to get those factorizations. So try to keep your work as user-friendly. Okay, I am the user, so I need to go evaluate your work. Now, with the next one, we have the square root of 5 plus the square root of 10. And those radicands do not match. And so you might try to simplify them. And so you would get this 10 factors into 5 times 2, but there's no pairs of numbers to actually get that simplified. So you'd be looking for a pair of 5s or a pair of 2s, and there aren't any, which means that these do not simplify. And if the radicands don't match, then you cannot add them. Do not leave a question like that blank. If you leave it blank, I don't know if it's because you're like, oh, they don't match, I can't do it, or if you're staring at it saying, I don't know what this problem is, I can't do it. And so you need to indicate something on here like can't be added, okay? Or you could say radicands don't match. Okay, that would be giving me the reason that they can't be added. But you would need to write something in response that lets me know that the reason you're not adding them is because they cannot be added, not because you just zoned out and don't know how to add stuff. All right, moving on. So we have a multiplication problem here, and the multiplication is with cube roots, and that's kind of getting at the idea that whatever you can do with square roots, you can also do with cube roots, fourth roots, and so forth. So math is consistent. Once you know how the properties work, you can apply them across the board. So for the cube root of 4 times the cube root of 2, now when you're multiplying and dividing, the radicands do not need to match. And when you had all problems that were multiplying and dividing, or all problems that were adding and subtracting, that wasn't an issue. Where it becomes an issue is when they start to be combined. And so you do need to pay attention to what the operation is and what you are and are not allowed to do. You can also use Desmos as a backup. And so if you're not sure if that works, okay, what you can do is you can put in the original problem into Desmos and then put what you think it's equal to into Desmos and see if you get the same number. If you get the same number, then you know it was okay to do. If you get different numbers, then whatever it was not an okay thing to do. Now remember, the direction said to simplify as much as possible, so you do want to take that cube root of 8. Hopefully you know that that is 2, just because we've been doing it a lot, we've seen that come up a lot. But if not, you can wedge in a little step in there where you would do that prime factorization of 8 is 2 times 2 times 2, and then say, oh, there's my group of 3, so the cube root of 2 cubed is 2. Okay, so that, but I would not require you to do that. At this point, you've probably seen enough, like 2 times 2 times 2 is 8, that you have it if you've been doing what you're supposed to do. All right, for the division, we have the fourth root of 162 over the fourth root of 2. And the easiest way to probably do this one is to kind of see where this goes. The fourth root of 162 over 2. And then you might want to grab your calculator, but I believe that is 81. And then again, of course, we want to simplify this further. And you've seen that come up. In fact, it came up earlier in this presentation, and I'm not even 15 minutes into this presentation. So we've seen that prime factorization of 81. If you've been doing your work, if you've been doing the work the way I've said to do it, okay, then you've seen a lot of these numbers before. So that is 3 to the 4th power, and the fourth root of 3 to the 4th power is 3. So you want to make sure you get those simplified enough. Now, when you see something on a study guide, that means that there is a pretty good chance that you would see a similar type problem. So you could expect on your test to see like a problem that can't be added or subtracted, just to see what you're going to do with it. You can be expected to see some that might have different kinds of radicals with them. If they, simplify on the study guide, there's a pretty good chance that they're going to simplify on your test as well. Okay, so these are good like example problems. Again, make sure you're not dropping the index on your radical and so forth. And go back and watch one of the videos if you, well, I'll get to that at the end. But like if you notice that there's a spot that's weak where you're like, I fell asleep in class that day, or I was absent that day, or something happened that day that you were not able to focus on the content, remember that there's a video posted in OneNote on that, and you can go and play that video. You can put it on double time to just kind of do that refresher for you. All right. I love these. Okay, so be able to simplify expressions involving exponents. Answers should have only one factor of each. Sorry, that's not what it says. Answers should only have each factor written once and have no negative exponents. So a lot of you got comments on your homework that said make sure that you're writing these with positive exponents. One of each factor. Here's what that means. So if you look at this, see how there's a factor of x in the numerator and a factor of x in the denominator? You don't want that. You want just one factor of x, okay? The y is okay. There's only one factor of x. The problem is it's got a negative exponent. So with these problems, I want you to remember that there's more than one way to navigate your way through these problems. And if you remember the lesson on this, there were actually spaces in your notes where I said method 1, method 2, because there's more than one way to do this. I kind of wish I had not picked 4s and 2s for this, but anyway, here's the first one. Okay, and I'm going to take you through this the way I would do it. Because I obviously like the way that I do it. But if you are seeing something that you're thinking, oh, I prefer to do it like some other way, that's fine. Now, please, please, please remember that this right here, let me see if I can grab the highlighter, okay? This right here is division. That is 4 divided by 2. It is not 4 minus 2. Now, the reason I said earlier, I kind of wish I hadn't put like 4s and 2s in here is because 4 minus 2 and 4 divided by 2 is the same thing, but that's the only time that happens. Okay, just like 4s and 2s. Maybe something with a 0, but like let's not divide by 0 because our paper will explode. All right. Undefined operation. So anyway, we have the 4 and the 2. That's 4 divided by 2. So you can just do that separately. That is simply a 2. Okay, you could write 2 over 1 if you wanted to. Now, what I would do here is I'm going to leave, let me find the laser pointer. Okay, I'm going to leave x to the 4th alone because anything that has a positive exponent, you're good to go. So I'm going to leave x to the 4th in the denominator. But I don't really like negative exponents. So remember what negative exponents do. If you have a negative exponent in the numerator, you can scooch it down to the denominator and it'll become a positive exponent. So that x to the negative 3rd, I can write that down in the denominator and it would be x to the positive 3rd there. And then y to the negative 2, if you've got a negative exponent in your denominator, you can scooch that up into the numerator and that would become y to the positive 2. And then we just need to clean it up at this point. So multiplying fractions is the easiest thing you could do. You just multiply straight across. And in fact, this was all one fraction to begin with. So we should be good to go. 2y squared is what I've got in my numerator. And then in my denominator, I have x to the 4th times x to the 3rd, which would give me x to the 7th. If you blank out on that, okay, off to the side, not in the middle of your problem, because it will make your problem very cluttered and very difficult for me to grade. But if you needed to do this off to the side, you could. You could say x to the 4th times x to the 3rd. That's x times x times x times x, because that's what x to the 4th is. And then you can see, oh, how many do I have there? 1, 2, 3, 4, 5, 6, 7. X's all multiplied together is your x to the 7th. So you're more than welcome to do that. That's actually really good test taking. But please don't put that right in the middle of the problem because it makes it hard for me to grade it. And you don't want to do that to the person who is grading your test. You want them to be happy when they're grading your test. Okay, next one is 2x all to the third over 4x to the negative 2. So there's a couple of things you could do with this first, but I'm going to try to simplify just the numerator, okay? So I'm just going to, again, I'm going to do that scratch work off to the side. I'm not going to put that scratch work right in the middle of the problem, but I also don't want the scratch work to be chaotic and messy either because like I want to be able to look back at it. So 2x to the third literally means 2x times 2x times 2x. Now you can also do that with one of the properties of exponents where you would multiply the exponent through to all the existing exponents, but I'm not doing it that way. So 2 times 2 times 2 is 8. X times x times x is x cubed. So that numerator is 8x cubed over 4x to the negative 2. Okay, now remember that this is 8 divided by 4. It is not 8 minus 4. That's division. It's always been division. You subtract the exponents, but you don't actually subtract regular numbers because it is division. So 8 divided by 4 is going to give me 2. And then this x to the third is fine. Okay, don't mess with the x to the third. But x to the negative 2, I can like scooch that up into my numerator and it would become x to the positive 2. And then that would give me 2x, and then you would add your exponents together to get x to the 5th. Now, and it helps if you like box your answer in and stuff. I didn't do it with the first one, but you can also like do that expansion out. You can do this other ways as well. So just because I want to make sure I'm separating my work here, you could do this where you're like, all right, that would be x3 minus negative 2. And we all love subtracting a negative, but that is 3 plus 2, and you can get the x to the 5th that way. So that also works. Okay, now anything on here that you think, oh, I would have gotten that wrong, or that's what you want to write in your notes. Okay, make it like highlight it, stop the video, highlight it, mark it off, like make a little note to yourself, maybe that says, don't forget that is division, not subtraction. The goal of writing this down is not to give you a hand cramp or just to keep you busy. The goal of this is to review, and the more that you can recognize and write down, the more likely you are that you will remember it. Okay, let's look at the next one. This is 2x to the third all to the negative 2. So I'm going to do it the way I would do it. So I would recognize here that my negative exponent means that I can put that in the denominator and it would become a positive exponent. What's got that negative exponent? The whole thing, the 2x to the third. So this is going to be 1 over 2x to the third, and now that is a positive 2. Technically, I think you can leave it there, but that would not be considered like simplified all the way, okay, because you still got like the exponents raised to a power. So you can do that by doing like 2x to the third times 2x to the third. 2 times 2 is 4, x to the third times x to the third. Remember, we're going to add exponents, which is going to give you x to the 6th. And so that would be your final answer. You could also get there by doing this. You could say that that is 2 to the first, x to the third, and you could do it by multiplying those exponents. So 1 times 2 is 2, and 3 times, I don't know why I put parentheses around that. I didn't need to do that. And then, so that's 1 over 2 squared is 4, and that would be x to the 6th. You could also do it this way. You could have 2 to the first, x to the third raised to the negative 2, and do 1 times negative 2, and x to the 3 times negative 2, which give you 2 to the negative 2, x to the negative 6, and then you would move them both to the denominator, and then that would give you 1 over 2 squared is 4, x to the negative 6. Notice that all of those answers are the same, even though I just worked it 3 different ways, okay? Now, if one of those ways made sense to you, then do it that way. If and 2 of them weren't, just ignore them, okay? In fact, if you've already written all of them down on your paper, what I want you to do is circle the way that you liked, okay? Circle the way that you preferred that you would do it if you were taking the test. It does not have to be my way, okay? so like, I want you to do the problem in the way that's going to make the most sense to you. But it is nice to know there's different ways you can show your work. And a way to catch people cheating is when you start the problem doing it this way, and then all of a sudden leap over to this step because this step does not flow from this step, okay? And then I'm like, well, that is somebody else's work, okay? So you can do it any way you want, but you got to commit to, like, this is the way that I'm going to work the problem. Don't look at your neighbor. Your neighbor picked a different way, okay? All right. This one, I have a whole bunch on here. This is a low-level skill. Everybody should get these right. The only reason you get these wrong is because you do not study, because this is a super low-level skill. So be able to switch between radical notation and exponent notation. So you've got 2 of them that are radicals, and you're supposed to write them as an exponent, and then 2 that are exponents that you were supposed to write as radicals. Do not do extra work. You are just changing the form. So on the first one, the cube root of x to the 4th would be x to the 4/3. That's it. That is all you have to do. There is no work that you would show for this. It is a matter of knowing where to put the 4 and where to put the 3. The index is the denominator. The exponent on it is the numerator. Okay, that's it. The square root of x does require you to know a couple things. You need to know that the index on a square root is a 2. I looked at a lot of homework today that people were assuming it was a 1. And so this one ends up being x to the 1/2. This one here, y to the 3/5, you're just going in the other direction. So this would be the 5th root of y to the 3rd. And y to the 7/4, that would be the 4th root of y to the 7th. You can simplify the 4th root of y to the 7th, but it does not say anything about simplifying. So if it does not tell you to simplify, I would not do it, because you start doing extra things and then you might make a mistake, and then Ms. Taylor has to take off some points, which I don't want to do. So the simplifying was the first bullet point that we did. Couple of things before we move on from this slide. There are a couple of things that can be done to make these more complicated, like we can make the radicand a little bit yuckier. So we could do something like the 5th root of 2x all to the 4th. Okay, and that would be 2x grouped together to the 4/5. If you saw something like the square root of 7x, you would need to engage the grouping symbol around that, and you would get 7x to the 1/2. Okay, so those are a couple of variations that were on your homework that you might see. The last thing I want to say about this particular concept before we move on to the next is that you have to make sure that your exponents look like exponents. So if you have like 3 to the 1/2 and you write 3 and 1/2, I have to take off points for that, okay? No, those are not the same. So even with something like this, if you write x and you write the 1/2 like that, that actually doesn't mean anything with the variable there, like some unknown and a half. So definitely don't do that, okay? Make your exponent look like an exponent. If you're not sure if it's neat enough, you can ask me before you turn your test in and just say, Ms. Taylor, is it clear that all of these are exponents? And I will let you know if there's something that I think you should rewrite a little bit neater. But honestly, if you're aware enough to ask me that, it probably looks fine. It's people that aren't aware that it should be different that aren't going to think to ask, but do be careful of that particular that particular catch. All right, next one, be able to solve simple radical equations using the methods covered in class. So while these are doable on Desmos, there are some equations that I am going to ask you to solve and to show your work, because it is totally doable and it's great practice for the mechanisms for how we solve equations. Make sure that you work top to bottom. And if you want to pull your notes on this, okay, you can. So step number 1 was isolate the radical. The radical is the index, the radical symbol itself, and the entire radicand. So you want to make sure that there is nothing else besides the radical on that side of the equal sign. So if you need to add something, subtract something, multiply something, divide by something, do what you need to do to get the radical by itself. Make sure that you deal with adding and subtracting first before you try to divide. This first problem is already isolated. So step number 1 is done. Step 2 was undo the radical. And this is a cube root. So I will undo it by cubing. And that will get me the radicand by itself. Make sure that you do not operate on the radicand. So if you are cubing, you're not cubing the x minus 1. You're cubing to get rid of the cube root. So this cubing is getting rid of that symbol for you. So you don't need to deal with it. It is not doing anything to the radicand. The 4 to the 3rd power is 64. And then the last step was solve the resulting equation. You do not need to write plus 1 plus 1. I do it because some people need to see it. So your answer there would be 65. Next one. And this is 2x minus 3 equals 12. Now, I do want you to note that is 3 times the square root, which is not the same as the cube root. Okay, so those also are not the same symbol. Make sure that you know what you're looking at. If it's an index, it's going to be really small and tucked inside the hook. If it is a coefficient that's being multiplied, it's going to be bigger and written on the outside at the same size as the other numbers, okay? So what I have over here is I have 3 times the square root of 2x minus 3. That's my radical. So I need to get rid of that pesky little 3 over there. And since that is multiplication, I can undo that with division. And so that'll cancel out, giving me the square root of 2x minus 3 equals 4. Then my next step is to undo the radical. And in this case, it is a square root. So I can undo a square root by squaring. If you square a square root, you're going to get whatever that radicand is. So that'll give me the 2x minus 3. Make sure that you are not operating on the 2x minus 3. So nobody says 4x squared minus 9, which would be wrong anyway if you tried to square it. So don't square it because that's not even the right thing to do. So what you're doing is you're getting rid of that square root. 4 squared is 16. There we go. And then solve the resulting equation. So in this case, we're going to add 3. So that's going to give me 2x equals 19. And then divide both sides by 2. I would leave it as a fraction. You can grab a calculator and change it to a decimal, but 1, it's more work, which might lead to errors, which we don't want to have any errors. And the other thing that it might do is if it doesn't divide evenly, then it actually contributes to an error in the problem. I am doing a quick double check on all of that, make sure I copied everything right. Because if you get a fraction on your study guide, it would mean that there's probably, not that there is a fraction on your test, but that it's fair game for your test, because what I usually won't do is give you harder problems on the test than are on the study guide. So if the study guide goes up to that level of, okay, you have an answer that's a fraction, then it means like your test is going to be open to that level. And I would just leave it. Okay, next one. We have the 5th root of 2x equals the 5th root of 3x plus 1. And we want to isolate the radical first. And so in this case, we have two radicals. Now it's awesome if you can isolate them both, which can happen here, and they are both isolated. So that's great news. If you can't isolate them both, then you have a much, much messier problem. So these are both isolated. So my next step would be to undo the radical. Well, that is a fifth root, which I can undo by raising it to the fifth power, which will give me 2x equals 3x plus 1. Now, what you really want to do here is get all your x's on one side. So this is a little bit of a conundrum here. I tend to try to isolate my x's so that I can keep the x's positive, because I just like to avoid a negative if I can. The problem with that is that my 1 is sitting on the side over there with the 3x, and so that is going to necessitate me doing an extra step that I'm not super keen about doing. So, I'll do it out both ways so you can see it. So I can isolate my x's by take away 3 x's from both sides. 2x minus 3x gives me negative 1x equals 1. And then I have to divide by negative 1. Okay, and I get x is equal to negative 1. Now, you could also do it this way. So I'll let you guys kind of decide what you want. If you want to subtract 2x from both sides, 2x minus 2x is 0. And then 3x minus 2x is 1x. Now, this is the part that a lot of students will trip up on, is they'll do the minus 2x, and then they'll just like leave it as it's x plus 1, and they've lost their equal sign. But we don't ever want to lose an equal sign in a problem. The equal sign is at the beginning of the problem, and it needs to be at the end of the problem. So if you take away everything from one side, you end up with 0. 2x minus 2x is 0. And then you can subtract the 1, and 0 minus 1 is negative 1. So you end up with negative 1 equals x. Obviously, both of those work just fine. And if one of those strategies made better sense to you, then that's the one I want you to go with. But I do want you to see that, yep, it does make sense to do it both ways. So you can decide what you like. All right. Be able to state the transformations. So to answer this, you do need to know what transformations are. So transformations are your flips, your left, right, up, down, turn it all around, do the hokey pokey, okay? So you want to make sure you know your transformations. Radical functions are a little bit different than other functions in that they do have a visible transformation on the over the y-axis, which your parabolas and other like equations that have symmetry, we don't do a lot of those transformations. So you do need to specify if you're reflecting or flipping. I'm okay if you use the word flip, that's fine. But if you are flipping it, you have to state over which axis it is flipping. So for this first one, I like to go from left to right across and look at my transformations. So that right there is a flip over the x-axis. The minus on the inside is going to make this go right 1, and the plus 3 on the outside makes it go up 3. So I just like to list them as I go from left to right. There they are. Okay, same transformations that we've been studying all year, just you do have to specify what the flip is on these ones. And then I had an f of x. I must have been feeling like I wanted variety. Okay, the square root of negative x minus 1. And then again, going from left to right, if there's a negative on the inside, this will give you a flip, but this is going to be a flip over the y-axis. And then minus 1 on the outside means it goes down 1. Other transformations that you might see, obviously you might see it go left. Okay, we didn't have one of these go left. You could also see a vertical stretch, and you wouldn't have to give me more information than that. So if you're wondering what would a vertical stretch be, it would be something like that. Okay, if you had a number greater than 1 multiplied out front. And I think on your in-class test, I think that's all that you need for That's all that you need for the transformations. On your at-home test, they are harder, where we have like a transformation from an existing function onto like a new function. So you're not necessarily starting at the origin, but those are harder. So those ones are on like the open notes part, where you can go back and look at your notes. But for your in class, remember what I said, this tells you kind of where the difficulty level maxes out. And then when I'm reviewing, I try to let you know, okay, you could also have a vertical stretch. I'm not sure that's harder. All right. And then the last one, be able to state the domain and range given a graph. So I think there's 2 of these on your test, and you're going to have to state the domain and range. So, and I believe these are multiple choice. So you will not need to generate the domain and range, but you will need to pick it from a list. So a couple of things to review maybe. Okay, this is less than, this is greater than. Okay, and your less than would be left or down, depending on whether you're on the x-axis or the y-axis. So if you follow the little pointer, if you're on the x-axis, this is the direction of less than. If you're on your y-axis, then this going down is your direction of less than. Greater than is either going to be to the right if you're on the x-axis, or up if you are on the y-axis. So this is your greater than direction on your x-axis, and this is your greater than direction on your y-axis. Okay, so there's like that, we want to make sure we get straight. And then the other piece of information that you need to know is that your domain is your x's and your range is your y's. So when you are asked for domain, if somebody gives you the range, you do not want to pick that. Okay, so looking at this, the strategy that we did in class, I think I'm going to grab my mouse for this. You want to look at that endpoint. Okay, so that endpoint is going to give you that starting location. And for this particular problem, it is at -3, 1. Your x is the -3, your y is the 1. So when you're looking at your answer choices, okay, you should have x, you should have y, and the x has to do with a -3 and the y has to do with a 1. So that much we just want to get matched up. That has to do with your ordered pairs, okay, and so forth. And then look at the direction that it's going. So if I look at the direction that it's going to the left and it's going up. That's where, so the function starts right there, and that's the direction it's going. So if it's going to the left, then that is less than, because it is like that's the direction it's going. X values can be less than -3, and it's going up, so my y values would be greater than or equal to -1. Now you do want to include the equal to, because it is an endpoint. So if you see the right answer choice but the endpoint is not included, that is not the correct answer choice, because the endpoint will usually give you a value of 0, and you can take the square root of 0, especially on those x's. And so it's not undefined. That's totally fine. The square root of 0 is 0. So those are multiple choices, and you would need to pick, and they are in inequality notation. So at least on this test, they're in inequality notation. Now, just in case at some point in the future I change my test up. If you wanted to do this with interval notation, it would be -infinity to -3, and you would stop because it is starting out here at the -infinity, and then it's stopping when you get to the 3. So you're always moving left to right, least to greatest, least to greatest. When we do the y's, we're going to go this way, least to greatest, always least to greatest. So for the y's, it would start at 1 and go to infinity. And notice again, like you should be able to match up the x's, the -3 should go with the domain and the y should go with the range. So even if you mess up something with the brackets or the order, if it's multiple choice, you should be able to make a pretty good guess, or at least eliminate some answer choices based off of that. All right, so that is The review, that was the last slide, that took less than 45 minutes of video. So if you are watching this in class on the day that I'm supposed to be TDE, make sure that you have not just blindly copied a bunch of slides with work. And I know that I am not that entertaining to listen to, but you need to hear, you need to get that auditory explanation of the problem, not just the visual, because auditorily, with words, I'm explaining the reasoning behind what we're doing. If you have a weak spot, if there was a day that you were absent, remember that there are individual videos for each of these concepts because we spent an entire 90 minutes on each of these classes. So if you missed that and you never bothered to make it up, you need to do that. So put that on your to-do list. You are going to keep this until you take the test and hand it to me on test day to show that you have done your review work. If you are doing this for a retake, same deal, okay? The goal is to do better on the test than you did the first time. So you want to make sure that if there's a weak spot and the review video did not review it enough, that you are going back and watching the detailed presentation on that concept. Do the work, and I promise it will pay off in a better test score. I'm making no claims, guarantees about specific test scores, like you will get a B, okay? But it'll be better than if you don't do it. Otherwise, let me know if you have questions, and you guys know where to find me.